understand some of the reasoning behind these statistical tests so that we can understand how they work and why we can use them. So I want you to envision a local hotshot basketball player who claims that he makes 80% of his free throws. So you're like, okay, show me. I want to see the data. So he shoots 20 free throws and makes 8 of them. And you're like, okay, well, if you're supposed to make 80%, I don't think that you would have only made 8 out of your 20. So I don't believe you. So that's the reasoning that we apply to test of significance. You make a claim, you collect data, and you see how likely it is to observe that sample data if the claim was true. An outcome that's unlikely if the claim was true is going to be good evidence that the claim is not true. And so the statistical inference that we've been doing, we're using samples to draw conclusions about a population. So these statistical tests are making claims about a population. What we're essentially doing is we're asking if sample data give good evidence against a claim. So with these tests, we're using those sampling distributions that we studied in the last chapter. And what that looks like in context is if we took many samples and the claim were true, we would rarely get a result like this. And to get a numerical measure of how strong that sample evidence is, we're going to replace that word rarely with a probability. So we'll use the normal distribution to actually calculate the probability that you would get a result like the one you got in your sample. So I want us to take a look at this example where we want to see if people can actually tell the difference between fresh brewed coffee and the instant variety. Most coffee drinkers will tell you that they prefer fresh brewed coffee, but maybe you think that people can't actually tell the difference. So we would set up an experiment to test this claim. So for this experiment, there were 50 subjects and they taste 2 unmarked cups of coffee and they say which one he or she prefers. One cup's going to have instant coffee and the other is going to have fresh brewed coffee. So what we're interested in here is the proportion of the sample who say that they like fresh brewed coffee better. And based on that sample, we're going to be able to determine if that's evidence for or against the claim that people can't really tell a difference between the different types of coffee. So in this hypothetical experiment, 36 out of the 50 subjects chose the fresh coffee. So that's 72%. So it seems like 72% is quite a bit higher than 50%, but we want to have a numerical number that shows us how likely or unlikely that sample statistic would be. So we're going to compare, actually before we get there, let's first just put this into a little bit of context. 72% is what we got in that study, but what if instead we had only seen 28 out of 50? So that would have been 56%. Now we're starting to get a number that's a little bit closer to that 50% mark, making us think that, well, maybe this particular sample was a little bit better than average, but 56 isn't really that far from 50. So where would you put that number as far enough away? Okay, would it be 56% is far enough away from 50% for you to think that people can actually tell? Or would you need to be at 65% or 70% or even 80% of people being able to tell which coffee was fresh, or preferring the fresh coffee rather? At what point are you convinced that people really can tell? Well, that's what we need to come up with, okay? 72% seems like it's stronger evidence, but by how much? How much better is that? So when we do a hypothesis test, it's a test of significance in your textbook. Hypothesis test is also what these can be called in other textbooks. But there's 4 steps. The first one is you make some claim. So in this example, the skeptic claims that coffee drinkers can't tell from instant, and so only half would choose the fresh brewed coffee. So here, the claim is that the population proportion is only 0.5. So you're going to make some claim about the population parameter. And that's essential here. Your claim is something about the population. Then we create the sampling distribution, just like in chapter 21, where you specify what the proportion that you're assuming is, and then you calculate the mean and the standard deviation for that normal distribution using the same formulas that you see here and that we did in chapter 21. And so what we'll do then is, using our sampling distribution that's centered around our claim, we determine the probability of obtaining sample values. So 0.56 would have an area of 0.2. If we use our software, if we use that table back in the back of the book, we would see an area of 0.2. So that means the probability that you would have gotten 56 if the claim were really true, that only 50% of the people would choose that, you have a 20% chance of getting a value like this. So 20% is not really that rare in statistics. 5% is our cutoff. So anything more than 5% is not that rare. Anything less than 5% is considered rare. So here, we have to calculate the probability. It'll be done with Crunchit. We won't do it by hand. But for 0.56, that probability of obtaining that sample is 0.2. But for the p-hat that we got in the actual experiment, 0.72, the probability of getting that is 0.001. That's really unlikely. So that's definitely less than that 0.05 that we use as our cutoff between likely and unlikely.